anyone mind if I record this?
Go for it.
Okay, get a different recording when you...
Right, better line.
Yeah.
Recording in progress.
Hello everyone on YouTube land. This is the Wednesday the 5th of February 2025, and this is the open Zoom call and YouTube live stream bounce for EVO Labs, Distributed Autonomous Organization. Can you hear me in YouTube land?
Yes.
Okay. I think someone's obviously watching it in two places. Okay, excellent. Thank you, Artifact. All right, so I think we'll just go straight into it. If you could run away with it, Charles.
Running all the way, sir. Running all the way. Yeah, today we're going to go over what's been achieved in the last month, some of our challenges, some of our successes. We will have time for questions at the end, or alternatively, ask them in the chat in YouTube land or wherever, and I'll try to answer them as best I can when they come up. Okay, so our February update. We decided on our loader graphics for the website, something we'll talk about in a little bit. Our front end design is done, and we're comfortable with it. Our abstracted sign-in features have been implemented. We have 5 projects so far to be voted on, to be funded and voted and funded at launch. So there'll be some decent community interaction for that. The scientific process check investigation is complete. We need a knowledgeable AI to check applications, and then we believe a group of humans can then vet the responses of the AI. As we all know, if you've been utilizing AI, it can hallucinate a fair old amount. And we've also hired 2 full-time developers who are working. Tasks in progress. We're continuing development. Estimated time is somewhere between 1 and 3 months, depending on how quickly things work. We're talking to future partners to help with our needs in certain areas and establish synergies. We're asking every project which has signed up so far for more information, and we started populating this on Charmverse, but now we're looking at our front end and trying to work out exactly what information we should be displaying to people who may want to invest in these projects. What type of information would they like at their fingertips? We're investigating exactly how we can use an AI or an AI agent potentially for DAO activities and what this would look like. This includes trading bots at the moment. The legal incorporation is ongoing, and we're continuing to look at bugs and test the proposal workflows. Things that we'll be looking at and potentially have time to start, we'll be looking at the designing the soulbound token art. Again, as I mentioned, we're looking to see how much information potential funders of projects would actually want. So we're trying to work out to see if we've missed anything. We're talking to all sorts of people, from venture capitalists to angels to friends and family to people that we know who work in similar industries, and trying to work out if there's anything that we need to be providing. And we've started the process of looking for lab space. And on top of that, because some of these projects take quite a long time to convey to somebody who doesn't necessarily have an understanding of physics, has never heard of certain aspects of things that we talk about, we need to start developing ways of communicating our ideas in simple formats. So we'll be looking at creating 2-minute videos for each project to explain exactly how they work and what they do. And we'll be continuing with testing, much more testing. So let me see if I can just play this. I think you'll enjoy looking at this. This is something very cool that Tony Gibboni should get 1000% of the credit for. I don't really want to tell you what it is because I couldn't describe it well myself. But as far as I'm concerned, it looks incredibly gorgeous. So he made a coil, and he is essentially getting the coil on a certain frequency. You can see this frequency down there, and it creates these pretty patterns. So what we're going to do is we're going to use this as a loading graphic. The reason we're going to use this is I've been harassing Bob for about 2 weeks, maybe a week, to get his 3D model of his fractal toroidal moment, because in my head I was like, okay, we have the 3D model of the fractal toroidal moment, rolls around, does some fun things, you can see everything spinning. But as Bob will probably show you later, it's a bit busy, so we really like these frequency waves. We just think this is absolutely beautiful, so we're probably going to use something like that. And so we're fingers crossed going to we're going to kindly ask Tony to help us with that to customize it a little bit. Just thought I'd show you because we think it's really cool.
Is Tony in the call?
I don't think Tony's in the call. Tony
Okay.
is moving house at the moment, so yeah, he's in the middle of
I
moving
can fill
office
in
and
because
house.
I know
Yeah.
the history of this. So essentially, it is a coil that is wound on a particular angle, which you might be able to guess what that is, but I'll let him speak for when he does a proper presentation on it. And what he's doing is he's changing the frequency that's running through and then tracking where the standing wave nodes are on each wire on that coil. And what you're seeing is the coincidence of standing wave nodes as you are ramping up through the frequencies. And I think it's really rather beautiful. And he has a kick-ass music track for this, which I'm not hearing. Is that?
No, he's done us two versions. One had the
Okay.
cool music on it, and one was completely silent. And the reason why we went with the silent one is the music one has blank gaps in it,
Right.
so the room goes dark. So we wanted to just see the whole cycle going all the way through, and then maybe find a bit that we really liked, and then we could instruct him to go from maybe this frequency to that frequency and back again. So it was like a loop. So you were always seeing a loop when you logged in. That's the idea anyway. So
Yeah. So as Jason said on the YouTube chat, it's cymatics, but it's cymatics rather than sound on a cardboard plate with sand or in the water. It's the positions of the nodes on this specifically wound, a golden ratio wound coil with a varying frequency put through it. And essentially he's showing, and that's the end of it. So, and he's showing where it goes like two coincidence and three coincidence and four coincidence as you run the frequencies up. Okay, carry on.
Yeah, thank you, Bob. Yeah, absolutely, people. I really appreciate the explanation there, Bob. You did it justice. Okay, so yeah, we're looking forward to seeing your 3D model, Bob. That's basically, we need to see that today because it's awesome. I've seen it. It's class. Okay, there we go. Cool. So we've completed our front end design. So we did a rough mock of what we're doing for our website. Everything seems to be going well with that. We understand how it's going to be set out, what we need to bring together. We're using libraries which are open source and can be utilized for other things that we're doing. And we know which features we need to integrate. So that's going really, really well. Our sign-in for the login, the features have been mapped and illustrated, and they're on the screen here. We supplied this to our developers who have been working tirelessly. So I can play you a rough demo. This is after 2 weeks worth of work from guys who have never worked on the exact things that we've asked them to work on. So what they've been able to create is a very rough sign in. Nothing will be set out exactly as you're seeing on the screen. This is just to get it in situ so that then we can design it properly. And what you're going to see here is the ability for a user to use their Google account, it'll be X and I think Discord, as well as users a private one, a magic link, essentially to sign in, a password, an email, a mobile phone if you like, or a wallet, and it will all take you to the same place. So if anybody doesn't want to use Google account, doesn't want to give a name or anything like that, they can go through their wallet and could be completely anonymous. If somebody would prefer to use their Google account or something like that because they remember the password for those types of things, you can use that, and it'll all go to the same place. So what we're showing here is how we can connect our wallet to a pre-spun up wallet. We can bring somebody else's wallet in. So yeah, this is all in 2 weeks. So I'm pretty chuffed with what these guys have been able to do. And yeah, we're looking forward to what they can come up with in the next 2 weeks, really, 4 weeks. It's going to be absolutely amazing. So yeah, that's a rough view of what they've been doing in the last 2 weeks. There we go. So in progress, they're looking at the account dashboard. So they'll be creating a full dashboard for everybody so they can see their account. Everything will be white labeled to EVO Labs. Account abstraction. So everything. You won't need to know about a blockchain or anything like that, or authentication. So bringing in usable login methods, some session management. So that basically means you can log in once, it'll hold a session key for, I think they're going to do 30 days. So you'll only need to log in once over 30 days. And it'll pre-generate wallets if you need a wallet generated. So that's what they're working on at the moment. What we're going to do is bring in the rest of the developers over the next week or so for a larger developer call. If anybody wants to start working on that, well, on any of these tasks, more than welcome to have any of the volunteers working on it. So that's something we're going to try and up our engagement with. Okay, so this is this. I don't think I've even showed Bob this image. So Toon did this. This is something that will be quite interesting. It's just, a little taster for the future. So we've got our 10 launch projects, which will hopefully be fully funded. So that'll be the Bagel, the Wintex, the Lena AI, the EVH2O, the Timeline, Lion, Ultra Replication, the Hutchinson Replication, Cloud Cavitator, and the Hank Tank. And so 5 projects we're going to be voting on are a quantum experiment, a solid phase formation beam project, shoulders replication, a seismic forecasting system, and the read-write experiments. So that's just a little taster, just to wet the whistle. So I'll give you more information on those next month. Updates from Lion, Ultra, Cloudoff, and Hutchinson will come over the next month as well as we set up teams and get everything prepared for launch. On top of that, a data collection initiative has begun. So Chris, working with Artifact and Hank, are looking at a data collection solution that will be made available to anyone running projects or experiments. The goal is to provide a software tool that can collect, display, and export data for a list of basic sensors. The software will support LabJack initially, and with the hope to expand to cheaper hardware such as Arduinos. The purpose is to introduce a standard of sorts and provide a base platform for researchers to then expand upon should they need additional features. For clarity, the software will be open source, it will be free, but the hardware you may need to purchase yourself, or it may be part of a funding application. Okay, so what didn't work last time was the videos, so we made sure that all the videos should work. So this is an update from Hank. So I'll play the first one and then I'll talk over the second one.
The used plasmoid is eating away the soot on the cathode. It is very difficult, with my, you can see eating. Shit. Here you see the tracks. It was black. Talk. Now it's going somewhere else. Now it's on the other cathode. It would be logic to be here, but it's not logic. For, of course, plasma is doing something else, but now it's eating away. Oh, the soot on the cathode.
Okay, cool. I'm so glad that worked with the audio. So I'm going to play the second video because Hank doesn't actually talk on this one. He might do a little bit of swearing, but I don't think so. I think that was the last video. Okay, so an update from Hank. His vacuum gauge is damaged and it's not clear why. He suspects the plasmoids have been traveling through the vacuum tube. Actually, I can just... that, I think. There we go. That was fine. Yeah. So he's in the process now of having his vacuum gauge repaired. Last week he added an extra power supply so he can increase the current. He wants to see better double layers, and he needs to know if there is a current, if the current is the key. But as usual, something different happens when he messes with things. When he increases the current beyond a certain level, a plasmoid will be formed somewhere on the cathode, sometimes on a logical place that he's seen before, and most of the times it's from a hiding place. This plasmoid is different than before because it feels stronger. It can exist somewhere on the cathode for a long time, eating the soot. It creates a very well known for Henk eating path. It looks like a path of a snail, basically. In the morning at Henk's house, no doubt, you can see the traces of snails eating a path. And plasmoids have a similar eating habit, according to Henk. It's a good observation. What is also different is the voltage current characteristic. First, there is blue plasma, and then the voltage is about 500 volts. When the plasmoid starts, it's doing its eating, the voltage drops to about 250 volts, and the current goes from 2 amps to 4 amps, sometimes more amps. What is also visible is the plasma flowing between the anode and the plasmoid, an orange kind of glow, as he says. What is also visible are many sparks coming from the plasmoid, the cathode surface. He's not analyzed these traces yet, if they are true sparks or plasmoids, like Bob has shown us in many videos he's analyzed. So as a final note, he added, last Sunday he had some visitors. So Jan Rack and his wife, Cohen van der, I apologize, Cohen, for butchering this, Cohen van Vleerderen. So that is the gentleman who is being quoted in the communication system patent by Hal Puthoff. And the gentleman named Samir Al-Dumini.
Cohen is the scalar
gentleman,
wave
yeah.
expert. Yeah.
Yeah. So they studied the Henk tank and the plasmoids, and Henk explained the mystery of the hiding of the plasmoids. And Jan wants to start a plasma experiment in his lab in Prague, and we'll think about plasma system. And Henk hopes to visit Jan this summer in Prague, as he hopes Jan will get some new observations we can learn from. So that might be another little plasma experiment being set up quite close to you, Bob. That'd be very cool.
So he's Czech, so Jan would be Jan in
Oh,
Czech. That's okay.
Okay.
And he has experience in mainstream physics, and I think he's a very, very clued up guy. So I think he's keen to do a very serious replication, and we're going to try and support him in any which way we can.
Perfect. Absolutely wonderful. Absolutely wonderful. Okay. Right. So Mr. Paul Stevenson, doing some excellent work. So has drafted a research paper. So I'm looking forward to reading that. He's looking for volunteers. So anybody who would be interested in the project. I think what we're going to be able to do is create one of these videos over the next couple of months, and that'll assist with getting the word out there to help with volunteers. But if anybody is interested in contacting Paul, you can contact him through me. If you like, or I can put you into contact with him, whatever, or contact Bob, whatever you'd prefer. My email address will be at the end of the presentation. And so, yeah, there's some Clarify water testing service and potentially providing interim water testing kits. So there's something developing there with your testing kits, Paul?
Absolutely, yes. I think we thought initially that we could consider a postal service where we all used a central analysis system, simply because it was expensive to have lots of multi-channel test devices. But it's a lot less expensive to have 3 or 4 individual small devices at a reasonably low cost at each individual site. And of course, the reason for that is that what we're interested in is better water, not the best. So this is actually going to be a comparative study and a qualitative study. And it's more important that we have the same instruments than we have the best instruments. So I think we can handle that pretty well. I'm also looking forward to seeing what the volunteers are going to decide to put into the music directory. In the EVH2O file, I've started off a music directory. If people think they've got things that are of an interesting nature and are relevant to the water experiment, please feel free to put them in. They don't have to be too serious. My contribution is the water boys. You see the whole of the moon. And if anyone would like to expand on that, I'd be very interested.
Yeah, but very good. I mean, maybe I can get some 432 tracks from my brother's dance label, and they have some pretty intense vibes, but all in the 432.
I think this could give a whole new meaning to water music.
Yeah, and then the other one might be some like Buddhist gongs and
Oh, water gongs,
bowls,
absolutely.
those
Yeah.
kind of things.
A singing bowl with water
Listened
in
to
it. is a rather
432
nice
Marley
one.
last night.
Oh, awesome! Fantastic.
Yeah, so anyone out there who's interested and wants to do something that's going to be, pretty demanding in some ways in terms of good data and comparison, we may find ourselves making better water. Who knows?
Awesome, wonderful.
It's amazing. That's absolutely amazing. Yeah, looking forward to hearing more about that. I think I've got a couple of songs that I'd like to add to your collection, to be perfectly honest. A bit of Mozart, Beethoven, maybe some Bach, something like that. See
Yeah,
what's
but not Handel, please.
No, no, no.
He was
No.
seasick.
Oh, no problem at all. No problem at all. Yeah, looking forward to that. Okay, cool. So the timeline. So Martin and Sterling must be commended for their efforts and tenacity with this. So as I mentioned, I think it was last time, they forked Tupac Cabra. So that's a gentleman who's been making videos for Ashton Forbes. I think that's his Twitter handle. They forked his code, who already had the UFO timeline, and they've been looking at creating an early prototype that checks content that's uploaded for malware. It uploads the clean content to IPFS for web storage, so completely decentralized storage. He's looking at they are looking at manual approval gates for content. Has a manual stage to build the timeline index of content. So the next tasks they're looking are to push the index to our decentralized hosting solution for consumption via a front end. So to make it all work so that people can interact with it or at least view it. They need to settle on a hosting solution for the back end compute. So there needs to actually be some processing going on the back end. So one of the places they're looking for is protocols they're looking at is a cache, but there are a few other options for that. And they're going to be turning some tools into a programming interface for an admin as well. So those are the next stages, but that's going really well, and that's only been running for about a month. So they've done incredibly cool work. Okay, so the Leonard AI, spoke to Bob about this yesterday, chatting with Eric at the moment. He's been doing more research into the knowledge graph. We may need some community volunteers like Paul has mentioned for his project, but this would be to collect data and tagging the collected data. We have a vast, yes, thank you, Bob, collection of videos to go through to extract relevant data, articles, pertinent links, concepts, and key comments. We obviously don't want two people having to do the same 3-hour Bob video. So we need to create a database so that we all know who's done which video and what data has been extracted from that video. And we need to come together in some sort of collaborative effort to potentially do that, because I think everyone's in agreement that one person doing it on their own, that's a bit of a task, really. I'd feel a bit daunted if I had to watch all of Bob's videos from start to finish and take notes. Gosh, that would be a challenge. Sorry, Bob, but lot of content, mate. So the thing that Bob and I spoke about is barrier leads, which really. Sorry,
Jim has said on YouTube he's been doing summaries, and he's right, he has been. So he's been doing summaries already. So maybe reach out to Earthworm Jim.
Earthworm Jim,
Yeah.
please could you email me, please? My email is charles@evo-labs.io. Please email me and we can put you together if we aren't already in contact, because I will be honest, keeping track of everyone's screen names is almost a full-time job. So yeah. Earthworm Jim, if I haven't spoken to you, please come and speak to me, and then we'll put you in touch with everybody else, and we'd love your summaries, or at least to help with summaries to how that we could push that forward. So yeah, as Bob was mentioning, something called barrier leads. Now, I hadn't come across this. But if we're building a knowledge graph where individual nodes, represent entities like people or articles or patents or concepts, the edges of those nodes represent the relationship between them. While tagging data can offer those relationships, what we may need to consider is what the subtext of, for example, a patent is. We may need to ask ourselves, what claim does it enable? What is the point of the patent? Is it to obscure some crucial detail? So you're looking at this thing that may do this thing, but actually it does something else. So, i.e., what is the author trying to patent
Yeah,
rather
can
than
I come in on that?
go off, Bob?
but
Yeah.
basically, from reading a lot of patents, often the job of the patent is to secure some IP, but not necessarily on the thing that is the title of the patent or the way that the thing actually got patented. So you might want to, for instance, secure a low energy nuclear reaction cold fusion patent, but call it a heat exchanger. There is actually an example out there that people might be able to quote of this case where they're trying to get it through the patent process by trying to kind of obfuscating the real thing that is the important thing that's being patented. So it's like when you're looking at a patent, try and get out the hidden lead that's going on, the actual point of the patent rather than the headline of the patent is essentially what I was saying. And that's about really understanding what you're reading.
Extracting the obfuscation and making it evident, basically.
Yeah.
So, yeah.
Maybe this is somewhere to bring this in. I was thinking along the same lines, bringing up little weird things we've encountered as leads to explore. Like there was a 3M plant where they had a piece of film coming off and it appeared to make what was like a force field or a ballistic shield. I'll look it up, but it's like now with my new grasp of Leonard and, the geometry and everything, we may be able to re-examine that and figure out what's going on and develop something from it. And, let's maybe submit a patent or not, but it's definitely something we need to explore.
Can I make a point? The often patent titles, patent agents play a game so that you don't disclose the invention in the title, because sometimes those things get published in the application that's later dropped. And so almost it's a universal problem that patent titles don't reflect the nature of the patent.
Yeah, I was saying to Charles that they actually craft the patent so that it minimizes the number of search hits that would actually reveal that some aspects of the patent are already in the public domain or that have already been patented. It's a real art, and that is where you kind of have to, and that work, if we can work out that a patent is already actually effectively redundant because it is covered by an expired patent, or you find a patent that you really want to work on in the DAO, but you find out it's protected, but then someone finds out that there was this article that was published in New Scientist in the 1970s that basically covers the idea that the patent, that there was no digital record or there was no effort put in to find in the patent record, you can then cause the patent to be null and void, and you can start working on that. So
one more point. The benefit of these patents is in the general description and the references often provided in the patents. In principle, a patent is only valid if it is enabling. That means that basically it explains exactly how to do the process. This is often not the case. But I'm just saying they're good core information documents for those reasons.
Okay, Charles, do you want to come back and carry on? I was so rudely interrupted.
Mate, don't you worry. It's
Shut your bitch ass up, nigger. Shut your bitch ass up, nigger. Nigger, 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 nigger. Nigger, 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 niggers. Nigger, 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 nigger. Nigger, 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 nigger.
We solved this problem.
Stupid ass nigger, stupid ass
I
nigger.
unfortunately let him in, so it's
Fucking live. Fucking live, nigger. Stupid ass nigger. Stupid ass nigger. Stupid
nigger. Sorry, that was me being too trigger happy on the. There we go.
There's something.
I guess I'm gonna have to edit and repost the video. Anyway, sorry for those out in YouTube land. Carry on.
Thank you, Bob. What a wonderful interlude. Yeah, never mind. It's all good. All good. So Tony has sent us a wonderful update. He is moving to a new workshop at the moment, So we're going to see more updates from Tony, and he's setting up everything at the moment. He's gathering data to be collated into one place, so our our repository, and there'll be some new 3D material renderings to be shared soon. And work is in progress for a small documentary with Felix. More to be spoken about that in the future. So that's basically an update from the Wintex guys. So I know on the blurb for this, there was a section about AI in the DAO. We're gonna have to wait until next month on that one. The reason being is I just didn't have time. I've been absolutely swamped with work at the moment. It's been so much fun, but it feels like spinning plates at times, so I had to just put that one on the back burner. We may need to find experts within our community or either highlight them. I've got an idea for a few who may be able to help us with the buried lead situation, who can understand, and when they're looking at patents and articles, what is that obfuscated information? Because I think we'll have to do that in a decentralized way. We're going to try and set up a further mailing list for calls. So just to remind everybody, give everybody like some established notice on when next calls are going to be. Another thing we're looking at is pitch decks. Are going to be prepared for every single project, so just as well as the videos that we're going to create. So to create some of these videos, we'll potentially get Felix over to the UK, travel around to see people like Paul, and then we're going to have a meeting in Holland in April, where we're going to be doing interviews, we're going to be doing panels, we're going to be looking at devices, getting some B-roll. So yeah, that's going to be our plan, so that when we launch, everybody's got a lot of marketing that they can distribute on their favorite project, or just at least illustrate in different mediums exactly what things are and how they all work. So yeah, that's our overview of what we've been doing over the last 30 days. Lots to keep going with, and I think we're going really, really well. Yeah, I think we're moving forward very well. So yes, thank you very much for all of your help. I look forward to answering anybody's questions if anybody has any. But yeah, thank you everybody for all your time and effort and energy. Thank you.
Charles, thank you.
Thank you very, very much, Charles. So does anyone have anything they want to present? I'm going to take questions on YouTube and stuff. So, or do you want to present or ask a question? Raise your hand in the system if you can.
Right.
I think I saw Alex's hand go up first, so we'll take him.
Yeah. Hey, just for the record, speaking of pitch decks, I got a job for about 3 weeks as the general manager of an equipment share, which I'm very qualified for it. I ran a naval special warfare battalion that had all this type of equipment. And now I'm bending tortillas, but I got that job and then got out. But the point being, I wanted to be in a position to help convert their rolling stock to something like a thunderstorm generator, because I think there's a good argument to be made, like with carbon credits and everything, to retrofit these things with something like the thunderstorm generator. I've got a version of it that I made back when I was like 20 that I'd like to explore on the DAO using basically a bent around Hills tube on the exhaust header. We can talk about it later. But I wanted to put that on the record here and talk about making a deck to pitch, if not my previous company, another company to do that. So I think that's a good angle to go.
Thank you, Alex. Of course, you can get onboarded and put a proposal together and see if the DAO approves it. I guess that's it. How would you describe the process, Charles?
Sorry, sir. I was reading comments on the what.
He's got a proposal for a variation of something that he made earlier to deal with emissions from vehicles.
Brilliant. Yeah, if you want to talk about that, send me an email. My email was at the end of the presentation. It's charles@evo-labs.io. Send me an email and we'll talk. No problem.
Cool.
Can I make a comment?
Yes, Rupert.
Okay. It'd be quite useful, I think, for people entering this field to get some sort of three-dimensional visual image of what we're talking about in terms of, because we're talking about new cosmology. Well, it's actually old cosmology, and I was thinking about I'll just throw this one out and see if anyone likes it. You could describe reality like an iPad, right? Which is basically generating two-dimensional images that move to give you the impression of a three-dimensional reality. But where iPads get really interesting is the pixels are all connected, entangled, quantum entangled underneath. All right. Now, that, that could be like an easy thing for people to understand as a representation of like a four-dimensional spatial reality plus time, because you've got time happening on the screen. Anyway, I'm just giving that as an example because often you're describing all these phenomena and people are, well, it's actually, if you learned any relativity or any quantum mechanics or anything else, or then you get up into string theory, it's incredibly confusing. People need a nice sort of easily handleable idea.
Yes, I think you've got a point there. I tried to explain what we were doing to a qualified physicist who happens to be a family member.
Right.
And the conversation was very interesting. He actually got it in the end, or at least he got what I was saying. He didn't believe a word of it, I don't think, but it was actually quite a good exercise in trying to put down on one page of A4 what the world is like. And I think that the hardest thing for him was the unifying idea, the idea that this was going to do the unification that physics had been unable to achieve. And I think he did have a problem with that. I spent a page in my paper trying to write that down, which is the thing I've given you just to check that I haven't made a mistake. But getting a description that you can actually read or put on a short note on a screen that puts a person in the right universe is actually a very, very important project. And it should be on the front page of our website, if you want to be.
Ideally, we can do a 2-minute video of something which really gets the idea across.
Yeah.
So that would be the best.
Short and sweet and very much to the point. Very much to the point.
Brilliant. Yeah. Well, I'm just throwing that out there. I mean, I gave one example.
I'm still boggling over the whole business of a superfluid universe, but I think that is a wonderful way of thinking about it. And then the Russians come along and say it's like a jelly.
Not quite. They're saying the clusters are like a gel.
Right.
But the gel clusters are made of an ether that is a superfluid. So when they are formed into fractal clusters, they become gel-like.
Like a colloidal, exactly like a colloid, of course. Yeah. Okay. I mean, I get it, but I just hadn't really got my teeth into it,
Yeah.
So,
but that's the challenge.
Yeah, I mean, this is where I am. So I need to write down where I'm starting from, or I do a piece of research.
Yeah, I mean, from an ethos point on the DAO, it's essentially making the unrealized realized. So and making things that we can deliver that no one wants to bother investing into delivered to realize its benefits. So something along those lines where you're actually giving life to things that can make a difference. So we can brainstorm these things on a set, but it's a good idea to have an impactful, no longer than 3-minute video on the front end that just when people hit the landing page, they understand what it's about and it's for the public benefit. Yeah.
Right.
I don't think you need to get too much into the weeds because all theories may be wrong, and likely
of course.
are.
But the main thing is to give people that sort of something they can feel and touch and move around.
Yes.
I think the idea of the interconnectedness of everything is a really big thing.
For sure. Fractal really Woman just highlighted a video to me or to the community, but said, Bob, I hope you're watching this, on her YouTube comment thing, showing a video that was done, I think, in the 2010s, something like 2014, where they were showing the structure of DNA as being a coil within a coil within a coil within a coil. They actually video the whole thing, and at part of the animation, it literally looks like it literally looks exactly like that.
Like that, yeah.
I mean, not even slightly. It literally looks. If I frame this, I can actually capture the same frame that's on the video. It's something like that.
I mean, Bob, when it's normally nuclear DNA is like that. It's not a long chain.
Oh, yeah, well, and I replied by saying that's the second to last paragraph in Geverblis's 1995 paper, that when he was talking about that coil to a biologist, they said, well, that's how DNA is structured, and that was in 1995.
Maybe
can I
along
show you
the
this?
same
Just
lines of something to grab people with is like achieving neutral buoyancy in the Dirac Sea as how they move these big stones. Like you're tuning them to where they're buoyant at a certain level in there. And I think that's an area to pursue as well.
can I just show you this? This is like showing you that this field is rapidly evolving. See, Casimir effect.
Ah, right.
RNA. Can you read that?
Yeah, I can see it. Yeah. Of course, when you've got very small gaps, you're going to have these things occurring, aren't you?
Yeah. So I'm just saying, in the biological sciences, this is happening. It's beginning to happen.
Yeah.
Yes.
Right?
Yeah.
Sorry, I'm going to
Definitely.
be promoting a bit of information. This is also really good. I bought this book. Can you just read the
Yeah,
title?
I can see. Yeah, go on. Yeah.
Right now.
Yes. I
Well,
actually have the original book.
Yeah, this is the later version. There's a 1910 version.
Yeah, that's
which is the
what I've
old
got.
version.
Yeah.
This is
Thank
this
you to Carmen
includes
Miller.
yeah, this is the 2 volumes.
Right.
So he wrote also about quantum mechanics and later sort of integrating the old ideas of the ether with new physics.
But the Tom Bearden always refers to his 1910 book.
Yeah, and he also refers back to the papers.
I might take that as light reading when I go to the UK next.
All right, okay. And there's lots of great stuff. So I want to throw another book out there. This is also really cool. This is the guy who invented microprocessors, right?
Right.
And he's now saying you've got to look at the interconnectedness of consciousness and reality. Right? He's a good person. Right? Anyway, that's a little bit. But we should have a library. That's the point.
Well, on
we
that
should have
note,
a library
I'll
of basic
be
references.
on the, I think it's the 23rd of February. I think it's the 23rd. I'll be speaking at a online free-to-view psionics conference meet. There will be several well-known people in the field, including people that have been recently discussed in major so-called unidentified aerial phenomena disclosures. So I will trailer that properly in the coming days. Anyone else got any comments?
If I could, the quick teaser to the read write. Right now, it's there are a lot of different ways I'm considering of like trying out, not trying out yet. I don't have any prototypes yet. Just what the sensors are going to be. But the idea is if these like transient photons, solitons really are related to consciousness in a way, the idea of that right sensor is that if these things can't be detected from the outside, we would need a volume in which these things could exist, from within which they could be detected. So that cube that you saw one screenshot of, that would be a array of probes, and I would have to figure out, and I would like other people's input on this, like should we use dielectrics, but then the capacitance could wash out the signal or whatever. The idea of it is if these transient photonic solitons come into existence inside of this cube, we should be able to detect it by these probes, just by the influence it would have inside the volume. So this is related to that psionics thing you mentioned. If you do have people who are interested in write capabilities, and we manage to get one of these objects made with some like feasible sensing capabilities, I would like someday to get someone to remote view from the perspective of that cube. And I don't really care what they see. I hope to see them.
Okay, I
Toon,
get you. Yeah.
Toon, can I ask you something? It's Paul Stevenson.
Yeah,
Hi,
sure.
Toon, can you hear me?
Yeah.
Yeah, good. Listen, I was thinking about microbiology. You know, if you can't detect a single bacterium, but if you want to detect a bacterium, you put it in a medium in which it can multiply. Have you considered that?
Not really. The possibility that they could multiply is a thing, but
How
I
do
was
you
thinking
feed
of it
them?
more like a
How do you feed them? This is what I was getting at.
I don't consider the mind of a remote viewer to multiply as they are remote viewing. It's more like their mind is somewhere else, and if they can put their mind inside that cube, I would hope to be able to detect it. Maybe
But I
there is
mean,
something to the multiplication idea, but
suppose someone could
yeah.
trigger a photo multiplier. You know, I mean, come on, these are very simple, old-fashioned instruments, but there may be
True, but
something
these
there.
would be like single events. I would like to map it out as though it's a cloud chamber.
Well, yeah, I mean, absolutely. I'd be very interested to watch that project and how it goes on. I've got a feeling it's going to be fascinating.
Yeah, if the probes themselves don't interfere with the structures too much, there are a lot of questions to be answered. But and if anyone has ideas better than picking up the transient dipoles across capacitors or using semiconductors to as the voltage of the transient dipoles gets high enough to conduct current, there are a lot of really the only
maybe you could use a Kozyrev detector, like it's like a whetstone bridge, and have an array of those, because obviously they were discrete components. I think he was making them with back in the day, but maybe you could make a 3D grid of them.
the most promising idea I have is also the the most convoluted one at the moment. It would be to have those three different faces, all with like n by n probes. And the negative space of that could be an electrode of in and of itself, between which we could put some resin with like boron doped and nitrogen doped graphene or carbon nanotubes, which would make it a p-type and n-type semiconductor at the same time. So it would conduct poorly if there's no bias, but in the spaces where there is bias, it should start conducting better, whichever bias you apply to it.
I mean,
And
yeah, okay.
at that point, you could the probes that would start conducting more, you could triangulate where that bias was introduced inside the volume. And from that,
Maybe
you
a
might
way
be
to
able to
do-
get the structures.
Maybe think about doing remote viewing interferometry with remote viewers and the probes. There may be some angle there between the probes
Yeah,
and the remote viewers. I mean, I haven't thought about it deeply yet, but I think there's something there.
the primary thing I want to focus the attention on, because the way this could be like implemented, it's totally not pinned down yet. But the idea is, if these things can't be detected from outside the location they're in, you would have to make a volume within which its presence would be detectable, like radiation inside a cloud chamber. Although you can actually see radiation from the outside, and the clouds you can see using light. And these entities, if they are solitonic light and it won't radiate out, you would need to meet them where they are. The way to do
There may
that,
be a
big
way of
question
like
mark.
asking the remote viewer the right questions, sideways in order to get it to interfere with the sensors to get a result. I'm just thinking, especially the way remote viewing works, where you
I mean,
have to ask.
we have access to Alexander Parkhomov. He ran the psychic spy program for the Soviets. There's chapter 4 in Space Earth Human discusses it quite deeply, and it discusses detectors in there. Out of that work, he developed reverse bias diodes of a certain types for detection of at least streams coming from Lena experiments. And so I think there's probably a whole group of things too.
Were they thermionic diodes, Bob, or were they solid state?
They were solid state.
Because I was just wondering what happens if you had a thermionic diode and you were looking into the field.
Maybe, yes. I'm going to be discussing at some point the Henry Murray energy amplifier, and it clearly was using EVOs, and I think we have a new explanation for that in due course, which I think will be actionable. And if that's the case, we can take charge from not a very high probe and amplify that into usable electricity. So I think you already know with what I've shared in recent weeks how to do that, but sometimes I need to spell it out. So we'll come on to
I'm
that.
a bit behind on the previous videos.
That's all right. No. I'm not. You're not going to get downgraded or anything. It's not compulsory viewing. Okay, I'm going to see if there's any questions in the chat here. If not, does anyone else want to say anything before I talk about the 3D geometry?
I will mention, in relation to something Rupert said just a minute ago about the library, is that the goal of the timeline is to be a view of an underlying library that will be created. So there is a goal and the thought going into a library with with timeline being just a single view into that, and then we can expand on that as time goes by. So that is in mind as we work on this.
Great.
Fantastic. Okay, I'm going to switch my screen here for people on YouTube whilst I prepare the screen, which I'm then going to share on Zoom. So okay, I'm back in the room on YouTube, and I'm sharing here. So I need to actually choose a different image here. Okay, so this is, several people have sent this to me, but I'm going to talk through this because a lot of people see, firstly, can everyone see that both on YouTube and in the chat, in Zoom? Okay, all right. So a lot of people send me pictures, as one would expect, of various toroidal structures in play, and this guy is an artist in America called Titus Edwards. You can go and look at his work at instagram.com/KingTitus III. And he uses vapes. This is not an endorsement of the use of vapes or any other type of smoking apparatus. That is your choice, but I'm not endorsing it. But anyway, he's using that in order to create smoke rings and play with smoke rings on smoke rings. And of course, first up here, he's produced one smoke ring, and just like the old dolphin video I was looking back in 2016, he's providing it forward motion energy by pushing a pressure wave behind using his hand. He then gets ready to fire another soliton through the middle, which he's just about to do here. And what you'll see is this is a certain diameter, and as it goes to the frame, which is at 5.39 seconds rather than 3.67 seconds, you can see that it's got wider in diameter. And this is very important when you're looking at bubble rings underwater, like come from a dolphin blowhole, or when you are looking at, sorry, I need to flip back here, things like smoke rings. There's nothing that's really constraining the diameter of the ring, so it tends to diffuse outwards, even though it keeps quite good consistent energy within the torus itself. So he's just preparing another one that he's going to fire through the center channel here. Now, as hopefully you will know, there is a low pressure zone here that travels through and reaches up to here when it starts to splay out at this point. And he's going to additionally add a forward pulse of hydrodynamic pressure in there to shoot this one through the center. And you can see also this has its little mushroom with the little licks, which are very typical of hydrodynamics. You can also see, and this is something to note, you actually have the dense ring here, but you have this kind of gap. This is quite common to see, and it's actually reflected in the sacred geometry. But of course, this is way from optimal because it's, again, still spreading out. So this is at 5.8 seconds. When we go here, this one has actually come all the way through, and you can see it's penetrated the top here, and it's actually got some kink instabilities going on here. So it's got its own wave going around the overall soliton, and we saw the same thing in the Suhas Rauka sprites video, which really started my whole journey on understanding potentially what is going on. And you can see as the flow comes up here, this really is the only channel something can be punched through. Otherwise, it gets pulled off this way and pulled off this way. If we go to the next frame here, which is at 10.135 seconds, this is much wider now. It's starting to lose some of its intensity. But what's happening now, if you go back to the previous frame, this is now being expanded out. Why? Because this was pushed through here and accelerated through the low pressure, but also his pushing force. It came out here, but as it comes to this point, it's starting to be pulled out. Why is it being pulled out? It's being pulled out because there is a vector going here and a vector going here. It's literally stretching this ring. And in the next frame, you can see it's stretched it even more. And it's also, this one is starting to, with its low pressure in the center here, pull the top of this through it. But still, it's not enough to stop this from being stretched open. Okay. Now, this whole process was described to me by Dmitry Baranov when I was talking about the first 1/3 of slides of O-Day in October the 4th, 2018. He literally got up all very excited and started describing these solitons going through each other and going through and coming out the other side. I hadn't actually seen something of this level of what he was describing back then, but I kind of visualized it based on what I was understanding at the time. But what this is telling you is that there is a stretching at this point, and this is across the head of the Ukon Vsara, and this is the point at which you are making a lower pressure, and it's pulling that way and pulling that way. So there is this kind of like stretching, and this is how I visualize that a toroidal moment, fractal toroidal structure, will be stretching and therefore making it less dense. The space-time, the vacuum, the ether in front of the structure, and we already know it makes a dense pulse going through the middle. Now, if we go to the next frame here, you can see it's actually starting to get wider than this. And on the next frame, it does, in fact, the original one that was in front, and this one went in front, is now going to be in front, and this one comes behind. In fact, it goes off frame, but you can already see in the video that it pulls through and starts to come back through the center again. And that is a process that when the overall forward energy here goes below a threshold, they start to merge into one that's more intense. And I will talk about how Ken Shoulders realized his most energetic effects by firing an exotic vacuum object, and a few nanoseconds later fired another one. And it was only when he did that that he got significant energy gain, and he got something like 1,000 times gain in that process. And I'm going to walk that through in a future presentation. But in the work of the sprites of Suhas Ralkar, I never saw a soliton going through a ring and out the other side. It didn't matter whether it was coming from behind or it was coming from the side. It was always captured by the more powerful ring and becomes part of the Borg, as it were. And the actual structures in the water did not care about the direction of the water movement, and on bulk, it would just churn through it as if it didn't have a secondary motion to care about. Okay, so why am I focusing on this? I'm focusing on this because what you're seeing here is a system that has no real ability to maintain integrity other than the overall toroidal form. It's getting wider, and this is essentially what was solved by Winston Bostic. Because if you recall, and I'm going to stop the share here and move it up, Winston Bostic, he had a minimum of 2 toroids that came together over a magnetic field and became a tor of tors. And when you've got that, and eventually it was like 2, and then he did 6, or then he did 8, and he became very, very stable structures that are spinning around their toroidal axis, and a whole series of toroids that are chasing each other. So what you've seen in that video, frames from that video that I've just showed you, is a soliton chasing another soliton. Okay? But it's all in one direction moving forward. When you've got at least 2, and one's trying to move this way and they're coming from opposite directions, one's moving this way, they can chase each other round into a tor of the next level up. And this is where, like, actually Titus does another video where he blows smoke onto a table or a flat surface. And I won't show it here because I have to go into, well, maybe I can. Let's see if I can do that at the end. He blows smoke onto a flat surface, so you can imagine that the smoke is rolling on the flat surface away from his mouth. And then he pulls up with his hand, and it immediately forms a helical spiral that moves up. And that totally demonstrates the multi-axis hydrodynamic shear. But in all of these systems, whether it's bubble rings from a dolphin, this kind of smoke rings you see coming out of a smoke cannon, what you've just seen there coming out of a mouth, there's no charge separation in the system. You've just got particles trapped in air. You might get charge separation, at least on a polar sense, in water, and I think that's why it's materially different in the Suhas Ralkar sprites videos, because there is some level of charge separation going on. Certainly it's going on in ultra experiments. But when you get charge separation, you start to get orthogonally arranged electric and magnetic fields. And this is where my intuition came for how these things fractally assemble. And it wasn't until later that I saw the Zverblis paper and the Nevesky paper that I realized there was this thing called the toroidal moment, and that also can attract and follow behind each other. So, but in my head, a long time ago, essentially it was after studying the Hutchison fracture sample and seeing those orthogonally arranged things and coming up with the original EVO, I had this animation in my head of how this was working. and I haven't ever shared it. I'm going to do a full video on it, maybe on Friday or maybe in just over a week's time. But I think this is going to really help people understand where I'm coming from. So, like I say, one torus can be stable, but as soon as it stretches out, you've got a diffusion of energy. It still has that low pressure, it still has that stretching, which I'm saying in certain senses, when it gets up to the magnetohydrodynamic fractal toroidal structures, is pulling space-time in front and compressing it behind, which allows you to do these kind of weird propulsion systems that both the MHD pattern from the 60s and the 1971 patent from the British Railways Board and the ARV, all of these systems, they are producing this kind of effect. And certainly the geometry of the ARV with the capacitor plates and the 48 capacitor divisions around it would imply that it is exactly producing these substructures. So what does it look in 3D? Okay, so I'm going to had no idea how difficult it would be to
Bob,
Yep.
sound.
Sorry, yes. No, it's come back. It's just because I put to my mugshot and I haven't got the Mac copied over. So sorry for those people on YouTube. You're going to see this here. Sorry, you're not going to miss everything. I'm going to repost the video on YouTube. So you'll get the video later. Sorry. Sorry. Yes, sorry. Okay, you'll get it later. They're all complaining. I didn't press the button. Oops. Right. Okay, so I've only got the apples in this particular shot that I'm about to show you here. Okay, and the tors and the cones. So what you're seeing is the back face of the apple. If I show you the front face, you wouldn't be able to see the internal structures. Okay, so I have to show the back face, and when I go into Blender, I'll be able to flip it round in a minute. So this is just to show you this. Now, a couple of points that I want to lay out here, which I've mentioned in the past, but I haven't really gone into much detail, and it looks like the other application has crashed. So we'll just run with this, and I'll come to the fine details in a minute. Okay, so and there's the play controls down there. And so why you're not playing? There we go. Okay. It's only a fractal 2. Does your head get around that? Okay, so
great work.
So what it is the sphere here from the center of this sphere here, and by the way, essentially these spheres are 4 times larger than the fractal sphere below, because it's a D4D structure and it emerges out of the whole maths. If you go from the top of the apple to the center of the sphere here, and from the center of this sphere down to the center of this sphere, this is the golden ratio, and that was first shown to me by Tony Gibboni. So thank you, Tony. It just happened to be. I experimentally derived this. This sphere is in the Sothic triangle, and in fact, the position I had an experiment slightly further down, but this position is correct, I believe. This is on the boundary of the subtor, sorry, the supertor in space-time in the fractal level above always. And so if I actually go forward, and I've talked about this before, but it's interesting to see it firsthand. So if I freeze that, this the point of torsion and this is, I believe, why it's offset to one side, both in the experiments of Mikhail Solin, his quantum coherent nuclear reactor patent from 1992. He sees this triangular structure, which we also see at the bottom of the cardioid infarction with transmutation and these hexagonal pits in there. I believe the triangle comes from this area here, the interaction of the torsion beam that comes out of the n-2 in this case, and its interaction with the Tor on the fractal level above. And that goes through all space-time, both up and down, as above, so below. And what you can see in here, we have a wheel and two wheels, one going this way and one going that way, and that makes another wheel. So that is a wheel within this wheel. Now this wheel is coming in this vector orthogonally to these directions, and this is a wheel, and it's coming in orthogonally up here. So we've got two wheels here making a wheel coming in that way, and two wheels there making a wheel coming in that way. These are all rotating in the same direction, but orthogonally arranged at each fractal level. Okay, and it's only because this is pulling things through and it's chasing this one that it goes round this way, but it ends up by producing the torsion and the tornado that comes in that starts this one rolling this way, and this is chasing this one, and that ends up by essentially you need the wheel within wheel within wheel to get the overall flow pattern to be ultimately stable. The minimum is wheel within wheel within wheel, right? Beyond that, it starts to become more and more stable, but the minimum is wheel within wheel within wheel. And it's just the fact of how the electrodynamics works out. Okay, so if I play this through now, you might be able to see this one rotating around here. You might be able to see the substructures rotating around, but can you see the substructures of the substructures of the substructures rotating around? And you've got to then think of that going down and down and down. And it only works because a minimum of 3 levels. And that keeps the whole thing spinning. And it keeps the tornadoes at the macro level operating and functioning. Now, the other thing which I could show you in a different way, but maybe you'll just get it here because I can just scroll back, is what I identified is if you look at many of the samples that I've shared physically, the apple is an event horizon, okay, when it's spun up sufficiently. And in one of the experiments, the Huang reactor, we showed where the apple had gone and crashed into the copper plate, and it extracted some copper around the outside of about 100 nanometers or something. This is obviously some kind of event horizon on hydrodynamics, and it makes sense when you think about it. The interesting thing is that the edge of the apple on both sides of a minimum two yin and yang pair exactly and precisely define the size of the sphere at each inside hollow part of the sphere at every fractal level, as observed from experiment. So it's hollow in here, and this is when the overall matter waves collapse, this is the space of the amount of material that you end up as the shell of the hollow structures, if it can accrete that amount of material. But the actual sphere diameter is this section in here. Now, when you have 48, as I showed you, when you have 48, the adjacent spheres are touching this internal structure together. And then if you go one more, they start interfering, which is why I don't believe it's stable above 48. It's just, we observed nothing more than 48 in the experiment. There's no more than 48 in the ARV. There's no more than 48 in the Syrian stelae. So looking at technology, looking at the ancients, and looking at our observation, there was no more than 48. And then by building the geometry out to its logical extension, it just shows geometrically how it's not possible. Okay, so now obviously we know that the first stable geometry is 4. So we would have another one here and another one like this up there. Okay, but it would be just too much to see. Okay, but the first plasmoid that Winston Bostic produced was one coming from one side and one coming from the other to make the n level Tor with 2 n-1 level Tors. Someone sent me a video about the London Buddhist Centre, and there was the priest or whoever it is from the London Buddhist Centre, and he's doing a video. I will share it after this call, and he's saying that there is the cross Vajra, which you might have seen before, and he says that in Buddhist mythology the cross Vajra is the first point of stability, and it allows for enlightenment and the creation of all things. And that is the swastika. So I did not know that until earlier today. Obviously, we've observed this from experiment and derived it from experiment. Obviously, when you get 6, you get total stability, but the first point of stability. So I did not know, honestly, till today, that in Buddhist law, the cross Vajra is recognition of the path to enlightenment. And it says when you understand that, which is the swastika, you are effectively well on your way to understanding how nature works. It just blew my mind that I saw that today. So I'm going to share that video. So I'm going to go now into where is it? Blender, because I can show this from different angles. Okay, so and I can just set play on this. Can everyone see that? It's not quite so clear, but it's clearer in some respects. So I can go here, and I think I can go here. And I can, not so familiar with the zooming on this. Does that make sense to people? Okay, so I'm gonna flick it to here, and we're gonna go into orthogonal view mode. So I'm just flipping this upside down, and we'll go to the Y. So on the Y, this is looking from the bottom. Oh, sorry, now it's gone. Oh dear. Like I say, I'm not so familiar with Blender. Okay, there we go. And there we go. About that. Okay. Yeah, it's going out of frame. Sorry. Okay, so why did I choose this particular angle? If you recall from my referral to the Griffin Brock video of his electrode, I kind of did a video at this kind of angle. And so if you can imagine the aluminium plate is sitting with the ether torus vector going here and the counter torus there, material is being pulled in from this side and it's being ejected from here, and so that would be producing the co-limited beams that produces shadow graphs from the matter being destroyed. Or it could be just that it's coming through here and this is the fine beam. It's one or the other, and this is the yin and this would be the yang in that instance. But as you can see, they are fractally made up of substructures. Let's see if I can get this. It's going somewhere over there. Does anyone know how to center a frame on there we go. Is it going to do something weird? Okay. Okay, so we are looking at the top there. This is the bottom. This is the side. And this is just that aspect. So I can zoom into that. And so is it clear to people why this would be stable in a way that a normal smoke ring with only a single axis of poloidal motion? It's just a normal smoke ring only has the poloidal aspect to it. What you've now got is you've got two poloidal structures that have their own poloidal and counterpoloidal, and they are chasing each other. But it's in the ether. Does that make sense? Anyone there? Can you hear me? Are you just...
Oh, yeah.
It makes sense, Bob. Sorry, yeah.
Okay.
Yeah, in terms of motion, it doesn't quite click yet, but if you also look at the like electromagnetic component, the idea that at the boundary they these counter-opposing currents that are nested in the same structure, they cancel each other at the boundary. That
Don't they generate a net compressive force too?
Well,
a net compressive force pushing inwards. That's the sort of right-hand curl rule, isn't it, for a torus?
The Lorentz force.
Yeah.
I'm sure that also plays a component. It's the visualization is a lot. What I noticed most of all is that if you follow a single one of the subtors, that it does trace out one of those fractal toroidal coils.
Yes.
yeah, of course it would.
I mean, on the top level, on this top level, I'm not rotating this because it would just be too confusing. Okay, but in the full video, I will show how. See, I had this structure in my head from the beginning because I had to explain the Lion reactor, and the Lion reactor has this incredible track in it, where it is these birdies with a black hole in the middle and two cones on the side, but they are obviously a structure that's rotated in a number of different ways as the overall macro structure is traveling along. So I had to imagine that something was traveling along the copper oxide. Oh, I don't know why this zooms in to, it's weird. It's a bit tedious actually. I'm going to load this back in. Give me a second. Just load it back in and maybe I've moved something. Don't save. just let me load something else. Okay, hopefully this will be less problematic. Okay, I can zoom into it now. Right. I had to imagine a macro structure with substructures around it that were self-similar, that were rotating around it as it was traveling across the copper oxide, leaving those marks, but it had to be multi-axial in the way it was damaging the plates. And this is true of both the videos we've caught in Henk's and David Boutlier's reactor. And so when you see something in David Boutlier's reactor shooting off a spiral wave from the structure, I imagine that one of these, which there may be many of them at this substructure level, has become unstable and it gets shot out, and it ends up by producing, it works out its own path and it comes out at a helical path coming out, its own little microplasmoid, which is comprised of, by the way, 2 microplasmoids. And as you'll see, the spheres actually meet in the center. So there's this sphere that meets in the center of the opposite side, but there's another sphere in here that comes into the center, and you see this right from the very first hydrodynamic structures in these experiments that I saw. And those, I believe, are the glowy bits that you would typically see, and it's the non-radiating boundary for this overall N-1 substructure. And when you start looking at the various substructures, it explains all the observables. But the real deep cuts come from the central part of the vortex structure. So I'm going to press play again on that. So, like I said, I thought it's tough for me to actually have made this, let alone for someone to get it. But I've had this going around in my head, which is my own curse, for many years now. And it's nice to finally see it, and now it's done its thing. Okay.
But Bob, you explained it extremely well, because this is not hard to look at. There's nothing here that doesn't jibe with what you told us.
Right.
It's very well described, so don't feel bad at all. It's brilliant.
Okay. if anyone's got any questions on it. So what I'm going to hopefully do is hand off this model to my first business partner, which I was the first with him trainer of Lightwave in the UK back when we were in our 20s. And he is an expert and does stuff for Hollywood using fluid dynamics in Lightwave. And I'm going to make him make these different attractors. And the thing is, I suspect that at each fractal level down, there will be either a scalar or a exponent that will be applied to the rotation speed for each substructure. So, for instance, I've got currently in every 120 frames, in every 240 frames, I have each of these structures doing one 360 degree rotation. But it could be that at the top level it's 360, and then it could be, you know, a much larger. It could be 4 times 360, and then 4 times 360, and 4 times 360. It might work like that. I don't know. And some people could need to think about these things. I actually don't know because I work on a visual basis. So these substructures here are always for 1/4 the size of this, essentially. So the question is do the rotation of the internal structures, do they go up by a scale factor of 4 as well in terms of their angular velocity? What I can say for certain is that if you remember the Binjuan Huang Scream image, where we don't see the bit that crashed down, but we see the 2 bits that came, the 2 fat Oreos that came out from inside it. They were the wheels within the overall big wheel. They came down and one of those broke up and the 2 wheels came out. And in many other cases, we had an apple, and from the apple, 2 wheels came out, which means that once the bigger structure breaks down, the substructures that it is comprised of, they are still at functional levels of event horizons and coherence, if you get me. So a structure like this would break down in reverse order based on its scale. And this comports with the 1973 laser into nonlinear plasma and the replication in 2021 of laser into nonlinear plasma that was producing toroids of which are like the smoke rings, but they have at least got charged particles. Toroids with 1.36 thousand Tesla magnetic fields in their ISO magnetic field imagery. I forgot my point there, but anyway. Yeah. And so I'm going to walk, when I do the presentation, I'm going to walk through how, in my view, this explains almost everything we've seen. And to explain slightly more complicated things, all you actually have to do is to increase the number of toroids you have around a fractal level. Now, what I'm not saying necessarily is that these toroids actually rotate around. I believe a torsion flux beam is rotating around, a wave, not a physical thing, if you can imagine. There's a wave, not necessarily. And the reason I say that is because when we looked into a hemisphere in Henk Urian's Vega reactor, we saw 2 spots that were at the starting angle here. Where is it? Which is on the golden ratio line. So if I go here and I come out a bit, so this is the golden ratio line. Okay, we see 2 spots. Sorry, 1 spot here, 1 spot here. They are the yin yang, and then we see 2 more spots, substructures in there. And so it might be that they are fixed in location, just like the overall structure is fixed in location. If it's not in a free volume of air, or plasma, or gas, or in the overall space. Likewise, what's the other case? There's another case where we observe this phenomena of it being locked in place. And this might be where you're on a conductor or a paramagnetic or a magnetic material. But I think in the free volume of space, it won't just be the flux loops that are following each other on each fractal level, the actual toruses themselves would be following each other. Does that make sense? So we know that the balls, for instance, in the Sapphire project, in Henk Veker's experiment, they get locked in place. If you pull away the ball, for instance, like I've showed in a number of videos, I've shown the tube with the cone tornado going into a torus. But that is inside a sphere. But we've gone, using the camera, we've gone through the outside sphere, which is the so-called non-radiating boundary if it's fully spun up. And that would actually be here. So we're looking through the sphere, we actually look through the apple, we look through the subtor apple, and we're actually looking at the torus at this level, okay? So we're actually able to see the torus. Now, I don't know whether that's actually spinning. It looks like stuff around the outside is spinning, but this, I don't know whether this is spinning because it's actually in a free volume of gas. But when we see these stuck onto an electrode, it's probably that they are stuck in one of the orientations. And so you get the non-radiating boundary glowing, and you know the actual things themselves are not moving. Definitely they're not moving in the Griffin-Brock electrode at the -1 level because they've got fixed locations. And I don't even think they're moving at the N-2 level because we identified there was 24 substructures. So there was 24 at this level at the N-1, and they were very well defined in the other case was the triangular holes in the Amasa vibrator plates. If you remember, there's 2 triangular holes, and they clearly were not rotating, because if they were rotating, they would have produced a actual round hole, and they don't. So in that case, you would have how should we put this? You would have at the subtor level, you would have, rather than 2 like we've got here, you would have 3. Okay. Is everyone bored yet?
I was just pointing like Maple. Are you visualizing this as like a micro machine or a standing wave? And what's your opinion about what you're looking at?
I'm so, for instance, in the last example I gave, where you have 2 triangular holes cut into stainless steel, the only non-radiating boundary that was strong enough to cut was at the N-3 level. Okay, so
Right.
this is the overall structure on our steel, and then we have 2 triangular holes, so it would have 3 structures in here, equidistant, 3 structures equidistant. Okay, but the only one that was cutting was those structures themselves and the flux loop traveling between those 3 zones, and this one pulling a hole out. Okay, so it was only inside that area and inside the substructures. So it acts like a machine, but it is, I believe, such an intense magnetic flux, which it's just difficult to get your head around, because it's, as far as I'm aware, nothing has ever been shown like this. I mean, I've been spelling it out for years, but it's never been shown like this. But from what I've observed, it's the only way I can possibly see it fitting together. And this is how I saw it before the Schwerblis paper. This is in my head, the basic 2-side fractal EVO that I saw on, when was it, February the 20th, 2020, when I derived that structure from the Hutchison sample. It's the only way that I could see it would work. And nothing since has changed that. No physical data, no scientific papers, nothing.
Bob, could you explain why the holes are triangular? What is the sort of mechanical mechanism that cuts a triangle?
Rather than there's 2, there's 3.
Got it. So as they rotate,
they're not rotating. This is what I'm saying.
As they are rotated, I don't know. So
I don't think they rotate. I think what you have is, so I don't think they rotate when they're bound to a metal.
Right.
And they're not. So the thing wants to be free, but it gets stuck in place, and it does work in place. And it's only at the level which is at an intense enough flux that it's able to cut the metal. So in this, maybe if I bring up I can show you what I'm referring to, and that's probably going to be easier than you've got to imagine at the n-2 level, and bearing in mind you need this is one wheel that in combination with its anti-wheel on the other side makes the n level wheel. So the n level wheel is made by these two n-1 level wheels, and the n-1 level wheels, and the n-2 level wheel makes this wheel, and that is the minimum to produce a stable structure. Otherwise it doesn't really work, and that's what you've got when you fire those two plasma toroids towards each other to make a plasma toroid of plasma toroids. So let me get the
Bob,
yeah.
just you've presented a lot of the like higher level fractals of these structures.
Yeah.
Do you know of any composite structures of these of these EVOs basically that aren't just higher fractal levels? Like, can they form molecules? Do they have some structures
we
outside
know,
of just stacking them into more rings?
So I've shown in various Vega experiments that the non-radiating boundary is the point is the point at which there's no electromagnetic waves outside, but the toroidal moment is able to penetrate as long as you don't have 4 subtors. So this level will have a disruption beam that comes out the back of the non-radiating boundary, and it has a helical beam that comes through and out the top. Okay, and we've seen how this helical beam can cause other EVOs in a Vega experiment by David Boulier to go in, say this one's coming along here, this one's coming along here, this one will start orbiting around this one's forward direction if it becomes within the field of influence of the spin torsion beam that comes out the front. So it's an ether vortex. It's like almost like a laser beam that comes out in front. Now, if the back end of this links into the front end, they can then start linking into chains or into loops. If they link into a loop, they will pull in together and they will produce a fractal tor at the level above. Likewise, you can split them up like this. You can actually see this process within kink stabilities, and also even in Titus smoke rings. He'll make a smoke ring and he'll split it into 3. Even dolphins do this. They split it in. So even at the single level of a torus, you can get away with dividing them. But I think it's more interesting in the electrodynamic sense. And so when you see in the Henk Vega experiments, we've got an electrode, and then you see these spheres. The spheres are optimally arranging, and that is because we know that if you add up the energy, what will happen is you'll get more subdivisions at this level, so that you need a minimum of 2 to produce a ring. If you don't have 2, then you just have a line going through, and it's its own EVO, right? So you need a minimum of 2, and they need to come within their sphere of influence, and the sphere of influence is their non-radiating boundaries get close enough, okay? And so bearing in mind this is the apple, not the non-radiating boundary, maybe I can, let me bring in Lightwave and show you something here, but first I need to go and find something else. Now I'll do that now. Carry on, ask your question, fire away.
Still though, that would be a straight line that could then curl up into a higher order similar structure. But do you know of any examples of them combining into stable or time periodic, like Conway's Game of Life structures that that aren't just the line or a ring of higher order?
I see broken rings, strings, and spheres.
All right.
That's it. But like, if you've got
enough spheres,
if you've got enough spheres, you can make everything.
Because I was just thinking of turbulent systems and like certain patterns that emerge in turbulence, and I was wondering if somehow there was something.
Because if you can imagine, if you have a 2 or a 3, the disruption beam can penetrate the non-radiating boundary, go through the apple and out into the into space, right? And so that can attract and aggregate things in a triangular grid, in a regular box grid, and then ultimately into a buckyball kind of scenario with pentagons and hexagons. When you get above hexagons, it works on a different level of self-organization. So you can get several self-organization that are triangular, which leads to kind of like a hexagonal grid. Triangular, regular box grid, and pentagonal and hexagonal grids. And anything that's made like that. So it can be a tube, or it can be a ball, it can be a sheet.
Yeah. Okay.
And this is how you skin things. So something can be skinned with these things, and they're all locked onto the surface. But then, if they all form one non-radiating boundary, then that piece of material inside cannot be seen by electromagnetic waves. You understand? It basically disappears.
I think I do. Not sure if I can visualize it totally. And I was more thinking of actually treating them as separate elements that can form bonds with each other and form
they do.
structures.
They don't have infinite bonding. They have.
No. The bonding would be very limited, but also it would eventually end up as a higher order, same structure.
Yeah.
So yeah.
The other thing is that they feel the influence of the toroidal moments of nearby structures. And so whilst the non-radiating boundary will prevent electromagnetic connection outside of the disruption beams and the torsion beam coming out the top, the actual non-radiating, the toroidal moment can see into these structures in a way that you can't with the electromagnetics. And I think they can cluster like that. So I have argued this, and I'm absolutely certain pretty much, that's a funny phrase, but I'm absolutely certain pretty much, that the ball lightning cut in 15mm ball lightning cut is on the non-radiating boundary, which is actually at the, dear, come on. Yeah, I'll have to learn how to use this software properly. Which is to go full screen button? Go on, help me out here. There's got to be a button for that. Oh dear. The non-radiating boundary would stem from about here. Okay, from this part here, round. The very much smaller ball lightning or magnetotoroelectrical structures, they bind onto the outside of the non-radiating boundary. And those are the things that cuts the spherical section out of things. Do you get it? Because they themselves can cut.
Interesting. So we have one very, very, how would you say? I don't want to say simple, but like geometrically, it would be a simple structure in the middle, and then a lot of small ones clustering outside of it.
I'm going to have to bring it up because I've talked about this so many times, and I just clearly people haven't got it because I know you've seen quite a few videos. So let me see if I can find that image on the fly here, because it's very important to get this right. What am I doing? I can bring it up on YouTube, can't I? Probably the easiest way. Okay, let's try here. 15mm. There we go. And there we go.
Now, I have been struggling a lot to visualize how those weird traces in the copper would appear just from the surface of a ball lightning. You brought up the foo dogs, the flower of life that's on those spheres.
Yeah. You're gonna. It's gonna become very, very clear for people soon. So this is what I'm referring to here.
Is it a bunch of the small ones?
Yes.
On the skin of one big one.
Sometimes that are orbiting around their center of mass and on their center of attraction, and they might be. You've got to imagine that it's moving. The overall structure is moving in a direction, in a vector. Then the other structures which are in free space are moving around. And then those have got such structures that are moving around, which may be anything from 2 to 48. And it's the point at which they do some instance that they cause the damage. Okay, so
But it wouldn't just have to be structures with substructures. It can also just be really small ones, a lot
Yes.
of them,
Yes.
surrounding one huge
Yes.
structure with,
Yes,
of
you
course,
can.
substructure.
Yes.
Yeah, okay.
So here's our 15mm ball lightning cut, and on the video, hopefully you've seen it. Can't remember whether I ever shared it, but I'll find it someday. This is a piece of, I think, 10mm iron, and then on the bottom of this it had 10mm iron. There was some zinc metal to get things going, because zinc oxide is pyro and piezoelectric. Copper is photoelectric, and so it's to get all these different means by which you can increase the ionization in the environment. And then this is basically essentially instantly cut out. And if we go and look at the cut plane here, what you have, and it's absolutely spectacular. This for me is some of the best data that the project's ever been able to acquire. And thanks again to Henk for providing the sample for me to analyze. Let me just zoom back so we get the full res. Okay, so can I step forward? Can you see what's happening there? Can you understand what you're looking at there?
A lot of scoops taken out of the surface, and also the holes with the with the braids taken out,
this
basically.
This is an octagonal hole. So I would assume that the ball lightning, the micro ball lightning that was in this place, had 8 subtors, and they were fixed in position. And the torsion is causing the disruption of the copper here, because it's pulling ether through, so that it's exciting the atoms beyond their point of stability to hold the metal lattice together, and they're being disintegrated or moved or whatever, right? And the copper here is not melted at all. So you've got 100% effect, and if you look at the scale when it comes up in a minute, you've got 0% effect in almost nanometers away in copper, which is one of the most thermally conductive materials there is. This is just impossible by normal logic, okay? And this is a hole that is orthogonal to the screen. This is a hole, and this is a hole which is at 90 degrees. So you can see how these things arrange themselves, maybe with different scales of them. This one's hexagonal here, okay? So you've got different levels of fractality. Now, you combined the understanding that comes from this particular image of the cut plane with the, how should we put this, the Leonid Oroitskiev exploding metal foil producing a large ball lightning outside of the reactor that a few milliseconds later, from its boundary, breaks up into a load of very small ball lightnings. You can actually go and see it in his paper. And so what I'm saying is something inside is produced in that exploding foil experiment that comes out, it produces a macro ball lightning. The macro ball lightning on its skin ends up by producing a vast number of micro ball lightnings. And these are literally micro ball lightnings.
Yeah, yeah.
Which
And each of those
in a fixed grid in the same way that you see on the Sapphire reactor, the same way you see in the Henk Vega reactor. You understand?
So maybe not quite as broad as chemical compounds in general, but definitely like graphene and stuff like that. Just yeah, okay.
Well, no, like if everything in your body is made from carbon as a starting point, right?
Yeah. I'm just thinking of amino
well,
acids, the little like ball and stick models. That would be difficult with the micro ball lightnings lining up perfectly like that. But these clusters and then smaller clusters clustering around that makes a lot more sense to make sense of this image.
You've got to think that the toroidal moment structure at an n-1 level is varied by 2 to 48 degrees as it goes round. Like you can rotate each of those 48 segments in different phases. And so the shape of that position and how that would attract something nearby would vary. but these things tend to organize into very stable structures. And I think the emergent phenomena is the shape of the human face, is the shape of a conch shell, is the shape of a cochlea. You know, these kind of things is the shape of, you know, a broccoli, is the shape of a sunflower. You know, these are the emergent things that would come out of arranging forms that have this at their core.
Bob, can I ask you a simple enough question?
Yeah.
It may be a bit silly, but I get the idea that we're sort of tiptoeing around the idea that there's a relationship between, say, electron, proton, neutron, and the miniature ball lightnings, that actually the particles are possibly assemblies of these fractal toroidal moments. Is that a bridge too far?
No. So you need to go and look at my friend and colleague who lives just up the road from me. And I forget his name. It's just terrible. He just sent me his latest paper. But when I started talking about this geometry being key to Lena, a guy in Germany sent me this guy's work. And basically, he says the electron is based of... his name is Pavel Osmira. Right. And you can go and look him up. And he shows that every element can be built from toroids, and he actually shows that the electron is a toroid made of toroids, right? So he came to the same conclusion, but he's a professor or was a professor at the University of Technology here, and he's actually won awards for that model. He's not the only person. When I started talking about it, I was sent about 4 or 5 different complete theories of matter based on toroids from the Soviet research. So this is known very well in Soviet spheres, and of course Pavel Osmira was mostly living under Soviet rule, so he would have been influenced by these ideas, but I think his is one of the most developed. And of course what Shishkin has talked about with Karols and worked for the last 12 years of Dubovic's life with him, they are saying that the electron is made from whatever it is, 7.76 times 10 to the 10 elementary LC dipoles. So an electron itself is a fractal toroidal cluster of etheric matter.
Thank you. I mean, I'd sort of thought about that and assumed it was true, but it's good to hear, and that someone else has come up with it independently as well.
You're basically saying literally everything in the universe is built on this form, and that if you can get into how these things bind together, you can both create matter and transmute matter and destroy matter, because you are literally having the tool by which you can go in and noodle with it, and it's nothing to do with the Coulomb barrier. And that's the whole principle. And that's why I believe you are seeing this copper. Look at that. Look at that. So what's the scale here? 300 nanometers is the scale there. So I would suggest that the difference between this incredibly churned octagon and the area of copper which is not churned at all is over a span of about 5 nanometers. The idea that copper would not melt and then it would 100% melt 5 nanometers apart is absurd. It's just totally absurd. And then you would have an octagonal structure in there. I actually think I have some of these images in 8K by 8K. And you see this one is orthogonal to the viewer, and this one's pointing off at that direction, that angle. There's another whole pit here, which is completely churned up, but it's essentially orthogonal to this one. And so this is why I believe that this structure explains what's going on. And so let me just bring up Modeler, because I want to show you in more clarified terms. Just another point here. And when I do the presentation, when I'm referring to the various observations through time using the 3D model, it'll be a little bit more in depth than this just quick look-see. This is because I only made this model a couple of days ago. I've been wanting to make it for a very long time, but I was always confused about the precise angle of the cone, and I wanted to get that settled. And I wanted to resolve why there was 48 subsections, and now it just emerges naturally. So let me do this. Can I do it? Modeler. I'll leave that playing. Oh no, here we go. Right. Okay. If I go into the 3D view here, I don't know if it's going to come across for you guys. It's quite fine. So there's our up and down subtour, but as just vector art without showing the fractal subdivisions. But here is the macro scale of it.
Bob, can I ask you another related question?
Of course, yeah.
Is there somewhere where I can get hold of the overlay that you put on all your fractal toroidal?
Yeah, I have it.
The sacred geometry overlay.
I have it in some blogs. I keep sending it to people, but what I will do is when I've published this, I will actually collate those pieces of graphics for people.
It's such a good graphic, but it's very hard to find.
Yeah,
nice
it's
to.
Not that hard to find.
Well, okay. Well, if it's in your stuff, I'll have another look. But I really just wanted it without the benefit of a skull behind it, or what have you.
Yes. Okay, I'm gonna get the. Where is it? Okay, here. Right. Okay, that's the correct one. But anyway, this will do. And okay, so what I want to show you here is, and I need the inner sphere there anyway. So where is that? Okay. What I've got here is the actual proper cone angle, which I think I'm pretty settled on Robert Hutchins' version rather than the experimental version. The golden ratio is here, so the distance between the top of the apple and the center of the vortex, and the distance between the center of the vortex and the center of the disruption sphere at the top of the Sothic triangle notch is exactly the golden ratio, and that is true of every fractal level. Okay, so this fully explains, in my view, why we have the golden ratio in nature. Now, the second thing is that the apple, which we've defined and observed as the point of really highly destructive ability in certain levels of spinning up of the structure, that exactly and precisely connects with the central sphere there. Now, I've arranged these so that this isn't orthogonal, it's all in the same plane. And this is essentially what you see, and I'll show this when I do the full presentation on the Coptic Christian art. Essentially, the Coptic Christian art in the front of number 10 Downing Street from 1775 is that, where you have the two windows, and this is the angel of death and the angel of life, and you have the ray of the vector going through there. But it's all presented in that ancient understanding. And so what you're seeing here is this white line here is the non-radiating boundary of this substructure. So the tor here, which will be mostly glowing here, has a non-radiating boundary here. So this is why you get self-organization, okay? And the actual overall non-radiating boundary is out here. So you can imagine that if this wasn't spun up so you only saw a sphere, what you're going to see are two spheres at the non-radiating boundary of the substructure below, and they would be rotating around this central point. And this is one way that you get to see these structures physically in the work of Ken Shoulders, etc. just to lay it out. I'll do it now, and then I'll call it a day, because that's probably enough of what I'm going to talk about in the full presentation. Let me find. I can't see Adobe when I'm like that. Okay. File. Okay, let me find this image, and maybe I can just bring up Sphere here. No, not that. Somewhere. That's our node. Okay, so those are the non-radiating boundaries of the subtor. Okay, and how fast can I find this? Not very fast, probably. Oh, there we go. Ah, I surpassed myself. Okay, yeah. What you've got to imagine is that this large EVO is holding this overall structure together, and it's moving this direction, and these are initially bound together by the much larger structure. Okay, but what happens is that this much larger structure starts to fail, and the substructures then are not bound together by the large structure's magnetohydrodynamics. They then start to drift apart. Okay, and this is what we physically see in the aftermath on Bin Juanhuang's reactor. We physically see it. But here is Ken Shoulders observing it on video camera in the 1980s or 90s. If it'll stay there. Right. So he has an EVO which has got two EVOs in it. Right? And he says in the description here that coming from the EVO source at the lower portion of the pinhole camera image, the EVO is seen to follow a helical pattern of motion and decomposing into individual electrons as it moves at a rate of 1/10 the velocity of light. Okay, so this is a very, very quick, this is over a distance of 0.1 of an inch, and it's a pinhole camera with a very, very, very short exposure time. It says this is traveling at 1/10 the velocity of light, and initially it looks like a braided beam, and that would be where the macro exotic vacuum object structure is binding these two substructures together, and then the macro structure starts to fail, and so the substructures then are not bound together and they start drifting apart, and then at that level maybe they haven't got enough wheel within wheel structure, and they basically break up into individual electrons that then ionize the air. That's what you're seeing there. Now if this structure was to go through a piece of metal or something, then it would leave a helical trace with the cores of the substructures making holes, or some level, depending on their spinning up, maybe of the apple. So you would get a separated corkscrew going through the material. Does that make sense? I'll go into. Sorry, what?
Absolutely.
Do you think the corkscrew pattern is due to the rotation of the internal subtors, like, you know, a combination of the rotational inertia and the motion resulting in a corkscrew? Like there's some impulse passing through the non-radiating barrier of the whole thing?
I think in this case they are two objects that rotate around each other, which are fairly self-contained and consistent inside. But when they lose their self-consistency and self-organization, they break up into individual electrons, essentially. That's what you're seeing. But this is an EVO which is made of two EVOs.
Yeah.
And in fact, it is a single EVO which has two subtor structures, and you're seeing their non-radiating boundaries that are sufficiently spun up to probably blue shift the light. And so thermal photons are being blue shifted on the inside the non-radiating boundary, and the camera is being exposed to those. You understand?
I'm thinking about the propulsive element of it and what's
well, the propulsion is probably because it was launched from a point, And because when it's self-organized, it immediately starts forming a vortex, and they spiral around each other at that particular level of fractality. The thing about
we're
Ken
saying
Shoulders,
the same.
Sorry.
Yeah, we're saying the same.
Yeah, the thing about Ken Shoulders' work, and it's the problem with all pulsed systems, they can only achieve a certain level of fractality. That's why resonance systems are better. Resonance systems hold the thing in place and keep feeding it more energy, and it seems it has to reorganize into more and more substructures. And we know that this is happening 100% because we have strike marks from Henk-Uren-Vega experiment, where we're not doing what Bostic and Nardi did, or Bostic originally, where they had a defined number of plasma toroids that they were injecting to make one toroid of a defined number of subplasma toroids. Henk-Uren has a tube, and out of the copper tube, it has a cone going into the center of a tor. And periodically that tor becomes unstable for whatever reason, and it launches in the forward direction when it's ripped from its umbilical, and it goes off and flies in, and it hits the fused quartz. And sometimes it shows 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different subsections on its collision. So it means if you get something in a resonant position and you drive it and you drive it and it drive it, sooner or later it will reach a critical threshold and it will start chewing spherical objects out of the structure. Now, if it becomes unstable, it has two choices. One, to completely blow up, or two, to subdivide into two structures. So imagine you've got a 48 tor structure, and it's get enough energy, and it's got 48 tors and all of its sustainable wheels within wheels within wheels, and it suddenly decides, I can't handle this anymore, and I'm going to divide. If it's sufficiently energetic enough, it'll divide into two 24 tor structures, and maybe one will have 25, and those will form a new super tor at the fractal level above, and it'll consume the next spherical non-radiating boundary out from that, bigger than the one that it did at the fractal level below. And this fully explains the observed effects of Dr. Takaaki Matsumoto, where he saw spherical sections growing on the boundary and then consuming things, which we replicated in Henk-Uren's Vega experiments, starting in the crystal grains in where we saw these things building up. And this is exactly what you see in, for instance, the Hutchison effect, where you cut a steel bar open, it's got these spherical holes in there, right? Well, that's because they built the ball lightning at crystal grain boundary, and then it fractally divided into substructures, but it's always a spherical thing that it eats when the overall structure gets spun up to a sufficient energy level. What I'm saying right now is we're getting very close to really knowing that we know how this works. And yeah, I mean, it's a joy to share this with you. It's a deep honor. I could have probably hashed together something like this maybe 5-6 years ago. When was it? 2020, February the 20th, 2020. Just under 5 years ago. I could have hashed it together, but there was so much I was unsure about the structure. That it wasn't the right time, but I think it's the right time now. I think it's the right time this year because you're gonna know that using this structure, knowing how to build it properly, how to produce unlimited energy with it and propulsion at any point in the universe. You will know that you know, and then it's just a case of someone does it. It might have to be me, but if no one is game for it, but like, you know, I just. It's not mine to own, so it's the universe. It's the gift. Okay. Does anyone have any questions on YouTube? They're asking for a boom in YouTube. Boom, boom. I'll do a full boom. Oh, if it'll work. No, I can't do a boom. Okay. All right, Charles, are you still awake?
Yes, sorry, I had to dive off to go and deal with the child for a little bit. Okay. Yes, definitely awake. That was absolutely riveting. I really enjoyed watching that, and the animations are absolutely brilliant. Well done, Bob. Fantastic work, mate.
All right. Do you have any questions?
No questions. Not at all. Not at all. No, I just wanted to say thank you very, very much for everybody in the community, and keep up the good work. And we'll try our hardest to make sure that there's something amazing to report next month as well. So thank you. Yeah.
Awesome. All right. Well, thank you very much, guys. It's been a real pleasure. Any closing comments?
It's both extremely complex and really at the root very simple, isn't it, Bob?
It's the most simple thing, and it
Yeah.
is always perfect.
Yeah.
And you cannot improve upon it. And the scary thing is it doesn't matter whether you are in Malta, Cyprus, Egypt, Central America, places in Africa like Great Zimbabwe, the Forbidden Palace, the temples in Japan, places in Vietnam, the most sacred objects of most of the religions, both pagan supposedly and accepted. The underlying geometry that drives this process is everywhere, and it is in our faces. And at some point, if the Buddhists, as apparently they say, they believe that when you understand this geometry, you basically you're well on your way to enlightenment. You know, I didn't make them say that. I didn't go back into the past and get them to write it in their books of thinking. But like, maybe it is that way. But like, I have been given an amazing opportunity to meet some incredible people, and it's not mine to own. If I'm wrong, I'm wrong. So what? But it's certainly a very predictive tool, and it is as simple as it can get. It's a tornado making ring tornadoes, and that's it. That's it. And the geometry gives us everything: the spirals, the vortices, the golden ratios, everything. Self-organization, life, matter, antimatter, or destruction of matter, everything. Okay, I'm going to call it a night there. Thanks, guys.
Okay.
Thank you, Bob.
Yeah.
Well done, Bob.
I'll call
Bye,
that a
everyone.
night. Thank you guys on YouTube. All right. See you later.
In a bit. Bye bye.
Bye-bye.
Bye.
Bye.